Hello and welcome to my little video about how to run or how to edit, compile and execute the Fibonacci series or Fibonacci numbers on a emulated mainframe with the help of some modern technologies and also the help of some old technologies. And before we start, just a hint, so I take my time with that video and you just play me back on a little bit quicker speed on YouTube, or even quicker if you like. So that's what I usually do with all those tech teaching videos, and I'm fine with that, and I can just really slow down and take my time. So why is somebody in his 30s looking after the mainframe, and why is he dealing with that? So my personal reasons are, well, actually I work as a software engineer, and for me all this mainframe host thing was, or actually still is a blind spot, and I try to gain some insights here, and curiosity, which is always good. This really counts here. And as it happened, there was, what there still is, but we're going to finish that this week, a massive open online course in German language hosted by the Hasso-Plattner Institute. Open HPI is the platform. And just for the credits, I opened that for you. So that's the course. And yeah, thank you very much for providing that opportunity to learn in 6 weeks about some architecture, but also some software basics of modern and old mainframe technologies. And for companies, so this is at least what I've learned. So why would you still care about this ancient old technology? I'm not going into much detail here, but what I've learned is that the hardware is actually quite good and quite expensive as well. So this was a phrase from, I think, the last lecture. So it's the gold class in the data center. So everything is redundant and it's really well thought out over decades. And the idea is that you actually have this one big box, the mainframe, maybe redundant, another big box, but you have everything inside there. So many Linux boxes and ZOS, which is the native operating system. Your databases is everything in there, and then you just have everything inside. Versus the nowadays approach, or the current approach, to have multiple single boxes in a network, in a connected network, and they form together a big application. And then you have to deal, of course, with resilience. So what happens if one of those pieces fails? It's just, I think, a different approach. Also, this was really stressed throughout the course that, and I'm not working in the banking environment and the banking area, transactions are supported really well. So many banks rely on these online transaction processing facilities. And for me, at least what I learned in my environment, you have the good old legacy code trap. So for some reasons, and in our case, we actually didn't need this online transaction processing. We are running batch jobs, but for some reason we started in our environment to develop software on the mainframe. And 30 years later, there is still the code, and it's quite expensive to run it. And then you can decide either you port it to Java EE. Java EE is, I think, a good option in the mainframe environment. It's well supported, as I've learned. So you have to dig in the code and understand the old logic, and then really transform it to some new standard or some new code, or you just throw money on it. And the promise of the mainframe of IBM is that I think they are still binary compatible till the 60s, when they first came out of the mainframe, which is probably a nightmare for the engineers because they like to get rid of the old stuff, but it's good for the customers. And interestingly enough, if you read about function as a service, or if you play with function as a service, so this offered by many cloud providers, so you just really have a function you define usually in the web editor, and you execute these functions to convert some images, something like that. You are getting paid by, I think, CPU time. This is at least what I saw for the Amazon offer. And paying by CPU time, this is nothing new. This is, I think, has been done on the mainframe for decades. So this is maybe just some background why I got into this for 6 weeks and why our companies are still doing that. And let's get to the hands-on part. So the problem with the course was because I think it was hard to provide some tests, some playground environment. It was most of the time just really listening to videos or watching videos and studying the stuff. So really theoretical. And as I see myself as a software engineer, I need my hands on. So I set myself the goal to code the Fibonacci series, Fibonacci numbers in Cobol, and to compile and execute it on the mainframe, on some mainframe. Yeah. And so the task, just to give you a short recap of what the Fibonacci sequence is. I think it's a quite common task in computer science. So and here we have the definition that every number after the two first is the sum of the two preceding ones. This is what we read here. So, for example, 5 is the result of calculating 2 plus 3. 8 is the result of calculating 3 plus 5. 13 is the result of 5 plus 8, and so on. And this goes forever. And so it's basically a bit more complex than Hello World. And this is all what I wanted to do. So get a bit more feeling for Cobol, for the language, and a bit feeling for the platform. So how to execute a compiler and to actually run it. In a minute we have a look at a Python example. So I usually do Python C coding, and just to get a feeling for the algorithm, I first coded it in Python and then I ported it over to Cobol. And when I was Googling, that's what we all do these days, about how to do that in Cobol, the Fibonacci series, or how to recursively program in Cobol, at least what Stack Overflow said in a couple of articles, you shouldn't do recursive programming in Cobol. Maybe because of some Stack Overflow, but I thought that's not possible. It was just some advice given there by more experienced people than I am. So I decided to do it in an iterative way, which is doable. And this is how it looks like. So it's not. I think there are a couple of options to do it, and when you do it in an iterative way, you always, or you quite often, have a temporary variable involved. So here we have our first Fibonacci number and the second Fibonacci number, and we have a border, so a maximum limit, and then we calculate the new one here. So the next one, then we swap the members, and then we just compare if the new Fibonacci number exceeds this maximum result border or not. If it's still inside, we print it, and if not, we just stop. And just to show you that this thing is actually working, I have my little Ubuntu shell in Windows 10 running here, which is really handy. So this is the new Ubuntu subsystem Windows 10, and we have our fibpy file here. And when I just quickly on the console execute this, and so we've seen that our border is here 54. So if we increase that, we get even one number higher. So this is the series in Python, and my problem was that, as already mentioned, there was it's not really simple to get a 30 days access to a mainframe, which was really surprising, because when you compare to the cloud offers, Azure, AWS, it's really simple, in a matter of 10 minutes to set up a cloud access for a limited time. And also what I tried to achieve was a quick edit, compile, and execute cycle. So no matter what language you write your software in, what you actually want to achieve is you want to, well, edit your code file. You want to compile it. Well, this step actually is not necessary for a scripting language like Python. And then you want to execute it. And if you see an error here or a failure, you want to change it, edit, and compile and execute. And this whole thing needs to go really fast as possible. So when I usually code with test-driven development, so this cycle is, I don't know, maximum 2 seconds. So, and this is where actually the speed comes from, when you develop a bit more than just an if then else logic. And I wanted to achieve something similar. So my solution was, because I have no access to a real mainframe system, I used the Turnkey distribution version 4, and this is the page. So Turnkey bundles two things. It bundles the Hercules emulator. This emulator is capable of, this is just what I read, capable of running, I think, ZOS, which is the native operating system of the mainframe, up to the, I think, the most recent version. But because ZOS is not open to the public domain, so there are some tutorials how to do it, but you somehow need to get to the operating system. The only official option is to use MVS. And MVS is the predecessor of ZOS. I think it was just renamed somewhere in the 80s, 90s. And the version we are using was put to the public domain. Oh no, it was released the early 80s, I would say, around this time, 1982, 83. And this all together, this is the Turnkey distribution number 4. So it was recently updated. Right. And how to use it? So I was lucky. So when I set myself the goal to actually, write some Cobol and to execute it and compile it on the mainframe, around the same time a YouTube user called Moshix released some videos how to use this exactly this Turnkey distribution. So how to start it, how to navigate in this old operating system there, and this was really helpful. So let me just quickly show you that. So this is a bunch of videos. The user is called Moshix. Do we see him somewhere here? There he is. And this was really, I think, the most important one. So editing, compiling, executing a Cobol program. So this is what I studied, and based on that and with some own ideas, I produced that video, or the code which I show you in that video. So this is my mainframe, and we can start it now. It comes bundled as a zip file. This is all on that web page for Turnkey version 4. When you extract it, you get some files in directory, and we just started on Windows with MVS. And this is, I think it just takes a while now, which is interesting because it's not a big CPU load. So my computer is not too old, so it's 2010, 2011. And yeah, I think it's just sleep times basically. I don't know. So we just let it start here, and we go to the next thing. So how do I access my little local mainframe? I use C3270, which is a console program which also can be installed on a normal Linux system, but also on my Ubuntu subsystem for Windows 10. I show you the command line in a minute. And to code my stuff, I'm a big fan of Visual Studio Code. I try to use it as often as possible. Particularly, I think this whole idea of the Visual Studio Code to support many different languages via this plugin system is really promising. And as it turned out, there is also a Cobol plugin or a syntax highlighting support by Bitlang, which I am using. And so my idea was, when I was porting that Python code to Cobol and I was learning some syntax, I did everything locally. So I edited my file locally, and then I compiled it with a local Cobol compiler. This is actually nowadays called GNU Cobol. Nowadays GNU Cobol. But at least in my Ubuntu repository, which I'm using in the Windows 10 machine, there was just Open Cobol, which was enough for me. I mean, this is not a big program. And I had to do some tricks, so this is a good time to actually look at the Cobol code. Make it a little bit smaller. So inside this block with all those numbers, this is the actual Cobol code, and I would talk about it in 2 seconds, maybe 10 seconds. What we see here is a mixture. So to actually execute it, we need something like the make file for the mainframe, which is the job control language, JCL. And what we see up in this upper section and down here is a JCL code. So this file consists of some JCL snippets and the actual Cobol source code. And I started initially with just the Cobol code, which was fine, and then I added some JCL bits and pieces when I did my first attempts on the mainframe. And to be still able to execute this stuff locally and to code locally, I introduced those little 2 Linux programs, which also run in my, again, Windows 10 subsystem. So I filtered out the JCL stuff to a file called fibcop filtered, and then I actually ran the Cobol compiler. This is also something, so this is the Open Cobol package, so that's the name. By the way, that's a code-to-code compiler, so it compiles the Cobol code to C, and then it uses GCC to compile the C code to actually a binary representation. I tried to configure the standard or the language standard to something similar, which is supported by the mainframe, so that I'm not too far away, which didn't work. So this standard MVS gave me much more freedom compared to what I experienced later when I tried to get this code running in the mainframe. So things like uppercase, lowercase, underscore versus minus. So this was this configuration here was much more liberal than my really old compiler on the mainframe. But anyway, I gave it a try. This says produce an executable. This is the input and that's the output. So it's a bit C style here. And then at the same go, I execute it. And before we talk about the code, so just let me execute that just to see that. Oh, here we go. Did you see that? So our mainframe is already waiting now for input, which is good. But let us first compile and execute the Cobol code locally, and then we just talk about the code. So we grep. So I'm lazy, so I just use Control R, which is a search in the history in Bash, and so we produce this filtered output. So when I look inside here, so I just see my Cobol code, and then that should be also in the history. I run the Cobol compiler, and then immediately, if this succeeds, I run the executable. And here we go. This is Cobol code. That's the Cobol code executed. Sorry. And when we look at the boundary here, so that's the maximum value. That's set to 150. That looks actually quite good. And when we compare that the output to the expected result, so it's not a unit test. It's just really as in the old days, trying something, checking the output on the console. Yeah, there we go. So maybe we just memorize the last 2 or 3 numbers here: 55, 89, 144, and we look here, 55, 89, 144. This looks quite good. So let's talk about the code, about the Cobol code. A Cobol program, and I'm not an expert, I just learned enough to get this running. I'm actually not sure if I ever will need that again. Yeah, but just for curiosity, so I can say at least I've written some Cobol. You've got division, so that's like the major building blocks. So you've got the identification division. In my case, this is just the program ID. I've got a data division. In my case, inside this working storage section, I define my local variables. And there is an interesting concept, this is something you should read about when you're interested, called the picture clause, how you define variables. In that case, I define a 10 number long variable for my maximum value, basically actually for all of my 4 number values here. So max value, fib1, fib2, and temporary. And then we've got, as the next building blocks, the procedure division. This is where the execution happens, and we've got 2 routines here, or 2 subroutines, I think it's called. So it's loop and calc. Loop, I think we could name it main, but I'm not sure if there's a concept like a main in Java or C, so I just called it loop. And it starts immediately, execution immediately. So when it enters the procedure division, it just picks the first line, which is that thing, perform calc, until Fibonacci 2 is greater than the max value. And perform is the magic looping operator, the magic looping command. So you can do for loop style coding, while loop style coding, all with perform and different syntax variants. So, and this is one of the arguments of people who actually like Cobol, is that it reads like English. And I think when you say perform calc until fib2 is maybe missing greater than max value, that's true, but this implies that you also use good variable names or variable names or sub procedure or submodule names. And when we look in calc, so this is where the actual calculation is happening. So first we display the old value, and then we do the calculate the new or the next value, fib2. And then we juggle the temporary variables. So this is basically the same algorithm as here, but written in Cobol. I didn't learn too much about job control language, so for me it's just enough to well, that's the make file. This is and it's not limited to Cobol. You would have a similar setup with JCL surrounding the code block and with other languages. So this could also be not Cobol but PL1 or C or whatever language or assembler which is supported on the mainframe. What I learned in the video of Moshix is this thing with the message class, which is really helpful. So usually you execute or compile and execute your program. And then in the old days it was just printed out to a printer, which is actually a nice idea, that it's just some noise and it's printing all the time, and maybe most of the time errors before you get it right. What a waste of paper. And we like our green IT, of course. So message class H puts the output in a special internal list, in a special internal virtual printer, whatever. There's a special name for that, the out list or something. So it's not printed out, but we can see the result on the screen, which is good. Right. That's so much about the code. So the question was, when I was done with my first couple of iterations and I got the Cobol code, at least in the first iteration running, I tried to copy it over to the mainframe, and the best option, which was also presented in the Moshix videos, was to use an FTP server, which is built in the now I'm struggling, well, Hercules stroke MVS environment. So it comes with Turnkey, at least I think that's correct, and we need to do that now as well. So I just copy that command and quickly jump over to here, and it tells me that now the FTP server is running on port 2100. And maybe or maybe let's do the timeline later as a finish line. So let's go for it. So we've seen the code, and now we want to see it running in the mainframe. So first of all, I have to connect to the mainframe, and we are using this tool called C327T, and it's basically like telnetting. So this is the address, this is the port, which was set up to the same name as the protocol. And we log, oh, not input not recognized. So I think now log on is required. You enter user ID. Here we go. Herc02. All those users come predefined with the Turnkey distribution, so you don't have to worry about that. And you can read it in the manual, in the Turnkey 4 manual. Password is see you later. And this is particularly this part of the message or the mod of the date. This really reminds me of my old university days. And here we go. So now we're inside the main menu of this mainframe operating system from the early 80s called MVS. And all the proprietary IBM software was replaced by some, do they have open source? Actually, I don't know, public domain software, which at least like this first thing here behaves a bit like the original software. So when you want to learn how to navigate here, I refer to Moshik's videos. I just really want to copy the source file over and compile it and show you the output. So we do a ds list. The mainframe is using a very interesting format called data sets, which is, I don't know, a bit like folders, like global folders, which can contain files. So it's a bit odd for me. And this mainframe comes, or the Turnkey distribution comes predefined with some data sets I just use to copy my source file into. And when we look inside here, we see some old version of the code, and actually we can have a look at this. So I just changed that to make it a little better. I refactored it, so it's not fib1, fib2, fib3. Now we have temp, and I also changed the algorithm slightly a little bit. What we do next is we just copy it over, and then this should update in here. And what I've learned, this is a hint, when you use FTP to copy, you have to step out. So another times F3. Step out of this data set, either you get a strange FTP error message. So I, from time to time, like my graphical FTP client. Of course, you can use your own client, whatever. So see, okay. I'm single-threaded, I'm sorry. There we go. That looks good. So we are already inside here. I'm not doing navigation on the mainframe side. So this is the mainframe side. This is basically what we just saw in the here in the console. So this is the same stuff as on the console, but now we're able to actually copy those files. This is my local site here, and like with the old Norton commander, I just press F5 and just copy it, my Fibonacci, my version of the Fibonacci Cobol source file to the mainframe. And you also see, this is interesting, it says E, which I believe means it was edited, it was changed, this data set. So I go inside, and when I open this with E, like edit, I see now it changed a slight little bit. So now we have our temp, we have our max value up to 100, set to 150. And I press F8 just to scroll a little bit down. And this is basically my source file, which we saw previously here in the modern age with Cobol syntax highlighting. And now we're in the, I think it's called ISPF editor. Another horrible thing back from the ancient days, bit like VI, similarly complex, and I just decided to not learn it. What I've learned is that when you want to actually well take this file and execute it or throw it to the job execution subsystem, JES I think it's called, you have to enter submit, or I think sub is enough. Let's try that, sub. Here we go. And we memorize this number, so this is our job number. So now something is happening in the background, and I believe that even yeah, our console, our Hercules console, tells us something. So it says, here we go, look at this. Something has started. I'm just looking for the job number. I can't see it here. Maybe I just can't spot it. So yeah, there was something going on in the background, and let's see if this worked. So we go back all the way back to the out list. This is my, this is how I imagine it, a temporary virtual printer device. I press 8 and I want to see all jobs, and then I just scroll down. So those are all my attempts here. So we have now 59, and we press, I think it's select now, and then we just pray that did kind of worked. And then you go through that output, and we just look for the list of our numbers. And as we see, there is nothing to see. Oh, I changed a little bit. By the way, this is the compiler from May 72. I changed a little bit, and I thought it's not necessary. I think I know what went wrong. So let's quickly fix that. Up on, I think, console. So this is something I removed previously. I hope this was actually the syntax. I would just want to just give it a try. I copied that from an existing example on the emulator. So it comes with a couple of Hello Worlds example. I think also a prime number example. And for some reason, which you probably can read in the manual to actually see some outputs, you have to enter, I think it was up on console. If this is not working, I have a proper lookup. But first of all, I would just, you remember the quick edit cycle, the edit compile link cycle, execute cycle. So we just copy it over. It went quick. And what you see now, this is how I got closer and closer to a version of the Cobol source file also running on the mainframe previously. So this is what I did in the past. So I say ds list, I see herc2, I go inside here, I press edit, and I say sub. I remember 60, press a couple of times F3, go to the out list, CST star, press F8, and I just cross my fingers and pray. And here we go. So this was actually not thought out, but it worked at least. So we see, and so those are my Fibonacci numbers printed to some console. And this is actually where my knowledge ends. So the different output variants of the mainframe, but at least I see some computation result. And this was actually my goal. And just to finish that little video, I have for you a timeline. So what we actually did, and this is, I mean, just maybe the fun part. So when we draw a timeline with all the technologies we've seen in action here, so let me have a look at my little piece of paper here. So with this is the time, we are here in, I'd say it was 1968, where the version of the Cobol language we are using was released. So it was not the initial reason, but I think it was like the second or third version of the language. By the way, Cobol was, let me think the name. a great lady in computer science. No, we should look that up. Some credits to her. But I'm really bad with names, but she's important. So please help me out. Please help me out. What a Grace Hopper. Here we go. Grace Hopper. The lady who invented, or her team came up with the word bug. So the bug we're usually referring to, and she always she also phrased this nice term. It's always easier or simpler to ask for forgiveness than to ask for allowance, for permission. Sorry, for permission. So when you work in a big company like I do, this is actually a good thing. So Grace Hopper, she was involved here. Our compiler, we already saw that, was from 1972. That was the Cobol compiler on MVS. So inside our system. Then we have the MVS system itself, so our mainframe operating system, the ZOS predecessor, which was released IC82, or maybe we say early 80s, so this is more accurate. Early 80s. So that's MVS. This is our operating system. The emulator we saw in action, Hercules. The start of development here was 1999. It's the emulator. And my laptop hardware, so the thing which actually runs the whole bunch, was bought, my laptop, in 2010. And the code editor we're using, Visual Studio Code, this is the most recent version. This is from 2017 with Cobol. With Cobol syntax highlighting. So we have a nice timeline of almost 50 years now. Isn't that great, of computer science? And with that little timeline, I want to say thank you for watching and have a great day.